I'd like to share a solution to a very interesting problem. This is a LeetCode problem 232, implement queue using stacks. So we are given a data structure queue. We have to implement 4 standard functions like push, pop, pick, empty, except that here we're only given 2 stacks to implement the queue. So queue is just like a queue, a line at the airport. You come into the line and you get out of the line as soon as it is your turn to leave the line, right? So it is on a first in, first out basis, just like any regular queue of people. A stack is a data structure that's similar to a stack of plates, right? So if you want to reach the bottom of the stack of plates, you have to start from the top. You can only remove 1 plate at a time from the top of the stack. Here's the animation that I prepared. So this is the queue, and we are in this line. Let's say you are the first element, second, third, fourth, and fifth. So if you join first, you will be leaving first. If you join second, you'll be leaving second, and so on. So everything happens in a FIFO basis. Stack is, on the other hand, is a LIFO data structure. It works on a LIFO basis. It is last in, first out. So it's like a pile of plates, right? Pile of table plates. So you have a pile of plates on top of each other, and you can only remove them one by one. So if we want to actually emulate the queue, let's say we want to remove the first element. The first element is actually at the very bottom of the stack. So how do we actually do this? How do we approach this problem? Remember that we actually have 2 stacks. So what we do is a very interesting thing. We pop one at a time, the element one at a time from the top of the first stack, and we immediately append it to the second stack. Remember, a stack is just like a pile of plates. So if you put plates on top of each other, if you have an empty stack, you're putting the first plate, let's say element 5, you're putting the first plate at the very bottom, right? This is the basis of your stack. We continuously pop elements from the first stack, and we at the same time incrementally putting them in our second stack. So we have our element 5th, and then on top of this we put element 4. We take the plate off of the first stack and we put it on top of the second pile of plates. Then we do it again. We repeat the same process continuously. We take the plate, the element number 2, off of the first stack and we put it on the second stack. Now when it is time to actually reach our element, right, remember that stack works on a LIFO basis, so it is last in, first out. So this element was actually last in. Now this element was actually last in, now it is first out. So now we only have 1 element left. We return this element, and then we actually want to restore the state of the stack 1, right? So how do we do this? We again continuously pop elements off of the second stack, and this time we put them back into the first stack. So it is 2, now it is 3, now it is 4, and now it is 5. So remember that we actually wanted to get the first element. There is no first element, but there is actually the other elements 2, 3, 4, 5, and the order of them, the state of the stack is restored. If we actually look at the original position, we had our elements 2, 3, 4, 5. We wanted to retrieve the first element, and now at the very end we again have 2, 3, 4, 5, and we can repeat the same process again. Let's say if we want to get the second element, we will again continuously take the element off of the top of this stack and put it into the second stack, and this is going to be 5, 4, 3, 2, and then we can continuously get the second element, then we put them back again. Overall, I just wanted to share with you this pretty interesting algorithm. It is an easy problem, but nonetheless it's really cool. Let me show you the code again. So this is the pop function. These are the 2 stacks. The 2 stacks in Python are actually lists. Yeah, so this is a very interesting problem. Do go and try it out yourself.